Good morning, third graders. It's Miss Sunmyo, and I want us to take some time and check our DMA for week 25, day 2. It's Tuesday. So let's take a look at our first problem. It's a word problem or story problem, and we want to read the information first. So Tavarius has 2 pairs of pants hanging in his closet. Each pair of pants has 2 pockets. The question is asking us to find how many pockets are there in all. So, are we looking at adding, subtracting, multiplying, or dividing? Well, let's take a look at information that we have. We have 2 pairs of pants. Okay? And on each pair of pants, remember that each gives us a real big clue. On each pair of pants, there are the same number of pockets. There are 2 pairs of pockets. There are 2 pockets on each pair of pants. And they want us to know, or they want us to find how many pockets are there in all. So we're looking for a total number of pockets based on this question. Now, when we're looking for a total, we're either adding or multiplying. Now, if we were adding 2 pairs of pants plus the 2 pockets, then the question would say, how many pockets and pairs of pants do we have? And that's not what they're asking us. They're asking us to find out how many pockets there are. So we know that this is going to be multiplication because the pants are considered the groups and the pockets are the number of objects in each group or on each pair of pants. So 2 pockets per pair or each pair. That's what per means. Per means each. So I'm going to flip to the back here and I'm going to show my work on the back just like I've shown you to do in the past. So we're going to use 2 pairs of pants, and we are going to say that there are 2 pockets for each pair, and we want to know total pockets, all the pockets. So just imagine it. Here's a pair of pants, and there are 2 pockets on that pair of pants. And then we have another pair of pants hanging in the closet. And that pair has also 2 pockets. So 2 pockets for that pair and 2 pockets for that pair. So how many pockets are there total? So 2 groups of 2 would be 2 plus 2, right? Which is 4 pockets. So we have 4 total pockets. So we can say in our response, there are 4 pockets on the pants because 2 groups of 2, or 2 times 2, right? 2 groups of 2 gives me 4 total pockets, right? So we have our equation. We have a model that's going to show us how we can model that information in our story problem, and here is my response. Okay, so make sure that you are practicing writing out an equation, showing a model, and writing out a response when you turn this in. All right, let's take a look at our next problem. It's a fraction problem, and it's asking us to divide this circle into thirds. thirds meaning 3 equal parts. And shade the pieces to show 2/3. So remember, our denominator tells us how many parts are in the whole, and this is one whole circle, and we want to break it up or partition it into 3 equal pieces. Now remember, you cannot just draw lines going down this way and say that these are thirds. Yes, they're 3 parts, but are they equal parts? That's the important part. These have to be equal parts. So we cannot say that this piece is the same amount as this piece, or this piece is the same amount as this piece. So remember, with thirds, and especially circles, we're coming from the center point. There's our center point. And we like to make a wide Y. That's what I like to do to make thirds. So try to make this as even as possible using my wide Y. So does everybody see that Y there? And I label each one of these as a unit fraction. One of the 3 parts. One of the 3 parts. One of the 3 parts. So 1/3, 1/3, 1/3. Now, it's telling me in the numerator how many of these thirds we're supposed to show or count. So we're counting 2 of the thirds. So this could be 1/3, and this could be another third. So I'm just going to dot those with the green to show that they're being shaded in using my numerator as my 2/3. Now remember, we can also make equivalent fractions when we are using thirds. And if you remember, and this is going to be your discussion question, if I have 2/3, what's an equivalent fraction to my 2/3? Now remember, if I double my pieces, which means I cut these into 2 parts, and I cut every third into 2 pieces, now I have just created what fraction? If you said 6, you would be correct. So when I take those thirds and I cut them into 2 pieces, I have now cut it into 6 equal pieces now. If you noticed, there's 2/6 here, 2/6 here, and there would be 2/6 here. And so when I have my 6 equal parts and I look at 2 of these thirds, well, how many 6 are in 2 of my thirds? Well, here's a 6th, here's a 6th, that's 2/6, and here's a 6th, and here's a 6th. That's another 2/6. So I have 4/6. I have 4/6 whenever I finish breaking that up into 2 equal pieces to make 6th. So every third is broken up into 2 equal pieces to make 2/6. So this would be a 6th, that would be a 6th. This would be a 6th, this would be a 6th. This would be a 6th, and this would be a 6th. So for your discussion today, 2/3 is equivalent to 4/6. That is your discussion. 2/3 is equivalent to 4/6. So we want an equivalent fraction to 2/3, which would be 4/6. All right, that's your discussion question. Let's go on to number 3. We have 1, 2, 3, 4, 5, 6 equal parts, and one of them is shaded in. We have 1, 2, 3, 4 equal parts in that square, and there is 1 shaded in. So we have 1/6, and here we have 1/4. Now, if you notice, this 1/4 and this 1/6, look at the size. Remember, when you break up a whole into more pieces, the pieces get smaller. So my sixth should be smaller than my fourths. And if I'm just comparing one of each, 1/6 is going to be less than 1 of the fourths. And you can also use your fraction strips to also compare this information. So let's take a look at our last set of problems, and they are relating your multiplication with your division. So what we're missing here is we have a factor, and here that factor is here, but to get the quotient, we need to know this other factor. So when I multiply 8 times whatever number, it's going to give me 24. So I'm missing the number of objects in each group, or how many groups I have. Shouldn't matter because these can be switched. Factors can be switched, right? So let's count how many groups of 8 I need to make 24. So let's count by 8s. 8, and 8 plus 8 is, right, 16. And if I add another group of 8, I could add 4, which would be 20, and 4 more, which would be 24. So how many groups of 8 did I need to make 24? 3 groups of 8, or 8 groups of 3. So I could have even added 3s. But since I knew this factor, I knew that I could also use that as skip counting by 8s. Now, another way that I could do this is I could go backwards and subtract groups of 8, because division is repeated subtraction. So if I take away 24 and I subtract 8, that's going to give me 16. If I take 16 and I subtract 8, I'm going to be left with 8. And if I take 8 away from 8, that leaves me with 0. So I subtracted 8, 1, 2, 3 times. So again, as long as I'm using my understanding of multiplication with my division, I can get my missing quotient here to use to find my missing factor here, because our quotient is a missing factor in multiplication. So let's take 42 divided by 6. So we're missing, what can I multiply times 6 to give me 42? Well, if I multiply 6 times 5, or 5 groups of 6, is 5 groups of 6 42? No, 5 groups of 6 is 30. So we're close, but we're not close enough. So 6 groups of 6. What's 6 groups of 6 going to be? Is 6 groups of 6 going to be 42? No, because if you remember your thirsty 6s, you had your twin 6s, and 6 times 6 was 36. So if I add another group, and if I were to use this 6 times 6, which is 36, and add another group of 6, and I'm using my distributive property here, I could take this 36, add 6 more, which is 1 more group, and 6 plus 6 is 12, and 12 plus 30 is going to give me 42. So my missing factor here is 7, which means my missing quotient here is 7. So 6 groups of 7 is 42, or 7 groups of 6 is also 42. So again, we can think about it in taking this factor and switching it. It's called the order property of multiplication. 4 groups of what equals 16? Well, I could count by 4s. 4 plus 4 is 8, plus 4 more is 12, plus 4 more is 16. So when I get to 16, how many groups of 4 was I able to add to get to my total? Well, I could also take 16 and subtract 4, and that would give me 12. I could take 12 and subtract 4, and that would give me 8. Take 8, subtract 4, and I would be left with 4, and 4 minus 4 would leave me with 0. So again, using my division and using repeated subtraction, I could count how many groups of 4 was I able to subtract from 16? 1, 2, 3, 4. So 4 groups of 4 is going to give me 16. So I could use repeated subtraction with the division, or I could skip count up to 16 and use my multiplication. But either way, I'm able to find my missing factor by looking for my quotient here. So that's our week 25, day 2 solutions for DMA. Don't forget that you are using your discussion question for the equivalent fraction to 2/3 for your discussion answer or response. So can't wait to see you this afternoon for our equivalent fractions on a number line, and we will see you soon.